Hello dear students, this is your Engineering Mathematics 3 lecture. Today's topic is regression. This topic is from third unit, statistics. In previous lecture, we have discussed correlation coefficient. Here now regression. See, what is regression? If x and y are correlated, then in that case, we find the coefficient of correlation. Now, if x and y are correlated, if the points in scatter diagram lies on some curve, then that curve is called curve of regression. If the curve is a straight line, then it is called as a regression line. In such a case, the relation between the two variables is a linear relation. So this is the concept of regression. So the first condition is that x and y should be correlated. If x and y are correlated, if the points in scatter diagram lies on some curve, and that curve is called, then that curve is called curve of regression. And if that curve is a straight line, then it is called line of regression line. In such a case, the relation between the two variables is a linear relation. The lines of regression are used for estimating the value of one variable for a given value of other variable. See, regression line of, there are two types of regression lines, regression line of y on x, and then regression line of x on y. Now see, what is regression line of y on x? It is given by y minus y bar is equal to b suffix yx, byx into bracket x minus x bar. Now here, y bar is the arithmetic mean of y, x bar is the arithmetic mean of x, and byx is called the regression coefficient of y on x. It is called regression coefficient of y on x, and its value is equal to byx is equal to r of xy. R of xy means coefficient of correlation between x and y into sigma y upon sigma x. This is the formula to find byx. Sigma y is the standard deviation of y, sigma x is standard deviation of x. Now you know that what is coefficient of correlation formula, r of xy. Coefficient of correlation, its formula, in last lecture we have discussed the coefficient of correlation formula. See here, it is r of xy is equal to covariance of xy upon sigma x, sigma y. Now you put this value there, that r is equal to covariance of xy upon sigma x, sigma y. So r of xy is equal to covariance of xy upon sigma x, sigma y into this sigma y upon sigma x as it is. Now sigma y get cancelled, in numerator is sigma y, denominator sigma y get cancelled, and so the next step byx is equal to covariance of xy upon sigma x into sigma x square, and this is the coefficient, regression coefficient byx. Now put here in this formula y minus y bar is equal to byx into x minus x bar, the value of byx, and so it is y minus y bar is equal to byx is covariance of xy upon sigma x square into x minus x bar. And so this is the simplified formula of regression line of y on x. Okay. Similarly, regression line of x on y is given by x minus x bar is equal to bxy into bracket y minus y bar, where bxy is called the regression coefficient of x on y, and its formula is bxy like this, like byx, where byx is equal to r of xy into sigma y by sigma x. Like that, the formula of bxy is here. After simplification, byx is covariance of xy upon sigma x square. Like that, the formula for bxy after simplification is covariance of xy upon sigma y square. So you remember it. And so it is x minus x bar is equal to covariance of xy upon sigma y square to y minus y bar. So this is the regression line of x on y. Note that here coefficient of correlation is calculated from the regression coefficient, and the formula is coefficient of correlation is equal to r of xy is equal to under root bxy into byx. Bxy and byx, these are the regression coefficients of x on y and y on x respectively. You do the multiplication of these two regression coefficients and then take the square root of this multiplication, then you will get the coefficient of correlation. So this is the formula to calculate the coefficient of correlation. Remember it. Now the example on regression lines. The example: obtain regression lines for the following data. Now the observations for variable x and y are given here. Also estimate y when x is equal to 5 and estimate y when x is equal to 5 and estimate x when y is equal to 10. So extension is there. Now you first find the regression lines. Heading is obtain regression lines, means you find both the regression lines, regression line y on x and then regression line x on y. After finding both the regression lines, you do this calculation. You calculate y when x is 5 and then you calculate x when y is 10. Okay. Now to find the regression lines, first you construct the table. Now in the table, the columns are here, the variable columns, x variable column, y variable column, then the x square column, y square column, and then x into y column. Like the correlation example, coefficient of correlation. In the example of coefficient of correlation, we construct the same table, variable columns, x variable column, y variable column, x square column, y square column, and then x into y column. Same table you construct here. You do the entries here of x variables, y variables. Then you do the calculation x square. X square means square of every element in x column. 6 square, 2 square, 10 square, 4 square, 8 square, and so on. Same for y square column, x into y, simple multiplication of x into y. After doing the calculation, you calculate the summation also. Summation x means addition of all the elements in x, it is 30. Addition of all the elements in column y is 40. Addition of all the elements in x square, all the elements in column x square is 220. Addition of all the entries in column y square, 340. Addition of all the entries in column x into y is 214. So this is the summation calculation. Now you find the arithmetic mean for x and y respectively. So x bar is the arithmetic mean for x. It is equal to summation x upon n. You do the calculation. Summation x is 30. N means number of entries. Number of entries are here 1, 2, 3, 4, 5. 5. N is equal to 5. So put n is equal to 5. 5, 30 upon 5, 6. Arithmetic mean for y is equal to y bar is equal to summation y upon n. Summation y is 40. 40 upon number of entries 5. 40 upon 5, which is equal to 8. So arithmetic mean for y is 8. Now you find a regression line of y on x. It is given by the formula is y minus y bar is equal to byx into bracket x minus x bar. Now you know the value of byx, regression coefficient byx. We have discussed it here. Byx is equal to covariance of xy upon sigma x square. So you put here the value of byx, covariance of xy upon sigma x square. Now you know what is covariance of xy. Covariance of xy formula is 1 upon n into summation xy minus x bar y bar upon sigma x square. Sigma x square means standard deviation for x, its square. Actually standard deviation is always in square root, but square of standard deviation is here, so no need to write the values in square root. We remove the square root, so it is summation x square upon n minus summation x upon n whole square. This is the formula for sigma x square. Now you put here all the values from the table and so on. Y bar is here 8. Put y bar is equal to 8 is equal to 1 upon n. N is 5. Summation xy is here 214. Put here summation xy is 214 from the table. X bar y bar. X bar is 6. Y bar is 8. Multiplication of 8 and 6 is 48. Put here 48 upon summation x square is here 220. 220 upon n. N is 5. The calculation is 44 minus summation x upon n is nothing but 6 because it is a formula of arithmetic mean. 6 square, it is 36. So right here 36. X minus x bar. X minus x bar is here 6. So right here 6. Now you just simplify it, do the calculation, and then you will get here this step y minus 8 is equal to minus 0.65 in bracket x minus 6. Again you simplify y minus 8 is equal to, you solve this bracket term, minus 0.65 into x minus 0.65 into x, this minus and this minus plus 0.65 into 6 is 3.9. Then you transfer this minus 8 in RHS so that you will get the value of y. It is equal to minus 0.65 into x plus 11.9. And so this is the regression line of y on x. Now the deduction is here. You find the value of y. Also estimate y when x is equal to 5. So put here in the regression line of y on x. This is the regression line of y on x. Here put x is equal to 5. If we put x is equal to 5, then this is the value of y, 8.65. So this is the deduction. So this is the regression line of y on x. Now, next is now regression line of x on y. The formula is here, x minus x bar is equal to bxy to y minus y bar. Now bxy is the regression coefficient x on y. And the formula is covariance of xy upon sigma y square. We have discussed it in starting. We have discussed the formula for regression line of x on y, and you just put the value of covariance of xy. Covariance of xy, it is from the coefficient of correlation formula. It is 1 upon n into summation xy minus x bar y bar upon sigma y square y minus y bar. Now put all the values. Put x bar is equal to 6. Then 1 by n is 5, 1 by 5, summation xy is 214, x bar into y bar means 6 into 8 upon summation y square. Sigma y square means standard deviation of y, it's square. So you remove the square root sign because it is the square of standard deviation. 340 upon 5 minus sigma y upon n, summation y upon n is the formula for arithmetic mean of y. So arithmetic mean of y is 8 square. Y minus y bar is 8. Now you do the calculation here, simplify it. After simplification, you will get this equation here, x minus 6 is equal to minus 1.3 into y minus 8. And then you just simplify, you solve this bracket term, and then in last you will get x is equal to minus 1.3y plus 16.4 after simplification. Okay. So x is equal to minus 1.3y plus 16.4. Now there is deduction here for this example. So what is the deduction? Estimate x when y is equal to 10. Now when y is equal to 10, what is the value of x here? When y is equal to 10 means this is the regression line of x on y. Here you put y is equal to 10. If we put y is equal to 10, then we have the value of x, and it is 3.4. So deduction on regression line of x on y. So this is the example of regression line. You find obtain the regression lines, means you find here both the regression lines. Regression line y on x and then regression line x on y. Now next example, you take it as homework, you try to solve it. Obtain regression line of y on x for the following data. Also estimate y when x